Now, this is definitely definitely live. I'm not gonna put it down again. Let's just open the code that we had before. And we're gonna be cleaning up all this mess here. So I think I'm just gonna, unfortunately, change the UI a little bit so it's a little bit easier for me to read in the first place. If I can get it working somehow. Okay. Just want to make sure that it is actually live. There you go. Okay, so we are 100% live here. Let's open a new window so we can keep looking at documentation. Oh shit. And let me tell the boys, this is actually live as well. Okay, so what do we need to clean up this time? Well, this is it. So we just need a node ID and a frequency. I'm gonna remove all this stuff, hopefully. Okay, so I don't actually use this, do I? Yes, stream. So it's not needed here for now. Do we need the test data? Probably do. So this will be better suited in this. What can I do here? This is how I'm using it. Something like this. I have a map for this. Let's actually begin by doing the writing. I mean by simplifying all that stuff in the main first. So what do we have here? We've got initialize an error, so this can be put into a function maybe, so or is it worth doing that at all? Because I'm not entirely sure. Yeah, why not? Yeah, and in here we can call that, initialize. It hasn't initialized it, then we need to return. Put that C out now, actually. I'll leave it here. And this, we're creating the string for the audio. This is the next bit of code. It would be nice if we can get a stream out of this. I don't know what happens when you call it twice, but what we can do is we can have a optional of whatever this is, which is a PA stream. PA stream, which is a stream object, I guess, right? In fact, let's create a unique pointer. Create default stream or something. Oi, Becca. Oh, let me show you what this does. 1 second, stay on. This is actually pretty cool. This is what it does. It plays a song. I did it earlier. It might be a bit too loud, but listen. Opa. Space Odyssey. You like it? Play it again for you. Yep, that's what it does. And I got some example code from the online, so, and there was 3 viewers earlier, so I'll call that a success. Okay, so don't publicly comment on my stuff. No association. So yeah, we need to create a default PortAudio stream. So it has to return a unique pointer, really. Doesn't really take anything, does it? It does no input channels. Okay, yeah, number of input channels, that's what we need. Number of input channels. We will need a, that will just stay there. Stereo output. That will stay there, and then the sample rate per second. Frames per buffer, i.e. the number of sample frames that PortAudio will request from a callback. Many apps may want to use p frames per buffering. Oh, it's the internet. Let's have a look. Let's see. Okay. Let's have a look. Is the internet there? Seems to be fine for me. See if you can put on higher quality. See if that's available for me as a test. Because I hope it is, because OBS does high quality stuff. Like you can put on high quality like this is what it looks like for me. So let's place all this code here into there. Is the reading text good? Like size? Huh. Let me try and watch on the phone.
All kinds of gifts made for all kinds of gifts made for all kinds.
Yeah, on the phone it seems to be fine. On the iPing phone, won't let you change. Oh, that is weird. Because I have here like full quality. Yeah, I think it might just be you. There's an option to do high quality image or something, or you can set manually on the app, at least for me. So careful not to use your phone data because video will use a lot. This code is very boring. Okay, so here we're gonna all of this column there. It doesn't change. Oh, that is bad. Hopefully it's not for everyone. Oh, I have no idea what I did down with him. He was okay for a bit. Yeah, he should be okay. I'm on, unless the internet shit, but I think on the phone is fine. I've got the highest settings here on OBS, so hopefully it doesn't mess up. It did crash on my laptop before though. I had to turn it off. So the music back on. Lucas, você tá vendo isso aqui? Fazendo um stream aqui pro canal. Ninguém tá assistindo ainda. Eu tô fazendo um bagulho de áudio. Escuta aqui. É isso que faz. É pra criar áudio. Tipo, só Square Waves. Agora tá fazendo só Square Waves, mas depois vai ser... Vou fazer mais, tipo... Sine Waves, tudo isso aí. Você pode tocar o que quiser. Se você coloca nota, ele vai tocar as frequências. Ah, tinha 3 viewers antes aqui. Uns caras do meu Discord. Tá sem fazer nada em casa hoje? Ah, legal. Foi pra onde? Ah, Bonfire Night? É, aqui também teve, mas eu fiquei aqui com a Mini. Ela tá muito assustada. Tá lá embaixo da cama agora. If anyone's watching this in the future, I'm just talking to someone in Portuguese. Sorry. Aqui a câmera. E começar a fazer seu trabalho, né, Lu? Já comprou as coisas? O Arduino, tudo que você precisa? E tá um lag do caramba quando eu falo e você responde. Vamos começar a fazer online. Aí você me mostra o que você vai fazer, eu te dou umas dicas. Ajuda também. Acho que Arduino é C++ também, né? Então aí é facinho. Okay, so point that we pass the data. Aqui eu tô usando esse negócio, só pra você entender o que eu tô fazendo. O negócio chama PortAudio. É uma library que faz audio. Funciona em Windows, Linux e um monte. E Mac e o iOS também. Aí você passa as waves pra ele, ele mostra ele faz os barulhos. Ah, eu mostrei no Python, eu acho, né? Acho que a gente fez no Python. Isso aqui é o C++ dele. String data. Tá bom, tchau. Alright, back in English now. I'm not sure if there's anyone watching this. I think I might be on my own, so basically talking to myself for the future. But that's okay. So basically talking. Okay, so I'm basically creating a unique pointer for the PA destroy and PA stream. So let's do that. And what actually destroys the PA stream isn't actually a destruction itself, it's just I'm gonna stop running the stream, right? That's what it's gonna do, I believe. Open default stream, which will be this here for me to stop the stream. Okay, so it will basically be this, right? So this is what we're gonna put here. We're gonna close the stream. This is the code. Now it has to go into the destroy code. I'm gonna change the file a little bit here because it is a little bit too big. Preferences settings. Text editor. Font size, there you go. So instead of 20, let's change it to 16. I think that's good, right? There you go, that's better. I hope everyone can still see this. If anyone's watching, let me know. That was right, that was correct. Whole thing needs to go. Oh, the font weight has to be a little bit bigger. No, I think that's fine. Okay, this should end the stream. This should finish the audio stream. And now we can do a no pointer PA stream. Okay, so this I'm gonna turn it to that. And it's gonna return a no pointer here. A PA stream destroy. That should work. Yep. And then at the very bottom, if there's no errors, we're obviously going to return the PA stream pointer with the stream itself, right? Which is a pointer, yeah. And the same function to destroy it. I'm going to keep its comments here because I want to read it in the future and actually understand it a little bit more. A little bit more. Okay, so basically we have a create default stream that returns a stream pointer. So instead of all of this, we can just do auto stream, and that will be the create default stream. And that was before, what was it supposed to be? The number of input channels, 0, and then 2 there for output channels, because we have left and right channels. And the sample rate was 44100, I think. Came with a CD, and the data itself. Now the data itself should be there, right? PA test data. Or just PA stream data, I think I called it. And let's pass that into there. It's much better. So at least the code here is cleaner than it used to be before, but obviously we moved all of the stuff into wrapper functions, which is not a problem really. So yeah. So our main is already looking a little bit better. We obviously don't need this anymore. Start stream error. But for now, what we can do is get the stream pointer there. And there will be another stream dog app. Okay. Okay, so now what I can do is I can push this into a new branch. Sorry. My Git is a little bit all over the place today. So let's call it unique pointer for stream, PA stream. Checkout -b. Why is it not working? Ah, yeah. Sorry, this is not the message. This is the name of the actual branch. There you go. That's much better now. Unique pointer. I need to be very careful not to input any passwords into mistakenly into this. Okay, so now it should be on Git and I can merge it in, just have a review on Git. No, I don't need to do this because it's all my code, but I like looking at what I've written anyway to make sure. So audio waves is here. Your branch isn't protected. Yeah, let's protect it, why not? I require pull request before merging. Require status check to pass, no. Require conversion resolution before merging, no. Yeah, require conversation resolution, yes. Require signed commits, no, we don't need that. Require linear history, prevent merge commits from being pushed to matching branches. No, I'm not going to require that. Are we going to allow force pushes? Probably not. So let's... And then... Okay, so we're now protected. And if we look at the other branch that we have here, we can create a pull request. After I push everything, obviously. Okay, let's just push down. So what did I do? I removed that code. Did I remove anything? So we ended up adding 21 lines, which is fine because that's mostly the function definitions and whatnot. I've added all of this stuff in the anonymous namespace, right? Which we will then change it in the future. And this is all the code I've moved from main, and then the actual main looks a lot simpler, hopefully. Yep, so okay. Okay, so I'm going to bypass it because there's no other people to merge this. Okay, so that is cool. Now we've merged it. So what's the next step on this? Gotta make sure that I'm also playing songs that are not gonna give me a strike, hopefully. Okay, no, this should be okay. Okay, so I've got this function that creates the stream, and I can use the stream in the start stream. That was the first obvious thing that we could do. And we can start and stop the stream. Is there a function that checks if the stream is running? Let's have a look. PA stream. Is stream active? Oh, that's interesting. Determine whether the stream is active. The stream is active after a successful call to PA start stream until it becomes inactive, either as a result of a call to PA stop stream or PA abort stream, or as a result of a return value other than PA continue from the stream callback. In the latter case, the stream is considered inactive after the last buffer has finished. Returns true when the stream is active, i.e. playing or recording audio, or 0 when not playing or... Okay, so really, you know, if you want to make this as safe as possible, we should probably put this in there as well. So kind of like in the destroyer, that's where we would put the function before we close the stream. Yeah, it has to basically be here. So if PA is stream active, and then we pass the actual stream there. If it is active, we should also call that code that's gonna, you know, basically make sure that we stop the stream before we do anything. I'm not sure if we need to do this, but for safety, and because I don't know how the API works now, it would be ideal to actually put that in there. So this is, yeah, something like this, you know, this is what we're gonna put in there. Okay, so we have the stop stream there. Okay, so basically, if it tries to destroy the pointer and is active, we're going to stop it first. Which is a good thing to do, I hope. And then after it's done all of that, it's actually going to close the stream. Closing the stream is an entirely different thing. Ah no, it does say here, if the stream is active, it discards any pending buffers as if PA abort stream has been called. So really, I mean, I didn't read the documentation enough. So this should really not be here because it does that by default from the looks of it. So good. Less code that we have to put in there. Okay, so now the next big thing we can do is a start and stop mechanism. So are we going to keep this PA stream calls here? I would like to put this in a, you know, a start string function or something that takes the unique pointer itself as a reference. I'm not sure if it's good practice actually, I suppose. Can you pass? Yeah, you can pass them as... I know you can pass them as reference. I'm just wondering if it's actually good practice to do it, because I don't know. Yeah, maybe we just pass in the raw pointer and that'll be okay. Or is there anything wrong with the actual code that's here though? Yeah, now we can do an early return here with no issues, because if the stream goes out of scope, which would happen when there's an early return, it's going to terminate it. So some of the logic that we would have otherwise need to include down here, you know, to make sure that, you know, if the stream hasn't started for any reason, we would need to then close the stream and then terminate the stream and etc. And that might be different control paths than what it is here now. We can do an early return, which is a good thing. So basically, I think I am gonna essentially put this into a function as well. So instead of that, let's just call, you know, boo and start stream, and then this would take the PA stream there, and it has to be valid. But most importantly, there was something I was gonna do before. Can't remember what I was going to do. Well, yeah, definitely regardless, this is going to be put into here. Stream is not no pointer. Stream is no pointer, I mean. We're just going to return true there. Oh, sorry, false. Implying it failed. Otherwise, we continue with this, and now we have just an error here. That's spell error. That was already an error message. We also return false there. I mean, if everything went just fine, we can return through here. So the start stream code is actually very simple. It's just got some error handling in this. And I know that I've probably included more code than it was before. So we created the false stream here, and then we need to call to make sure that if it hasn't started the stream, we need to return a -1 or something. Ah, that was right. I mean, and by reflection here, by reflection, I'm not sure if that's the right word, we also need to stop the stream, right? So let's do the same thing here, you know. And again, we need to check that the stream is valid in this case. If it's not, we return that. And in fact, I'm going to put this into a nice little string because it didn't seem to work before. Oops. Also, I've got a link to my stream up. Now, why has this song stopped? Quite enjoying that actually. Error message, error message. Stream.get. We don't need stream.get anymore. And again, we return false here. And return true there. Okay. Okay, so we can now start and stop the stream quite easily. Do we care if the stream has not stopped though? I mean, probably. Love when the indentation doesn't work properly. I mean, do we really care? See, the ideal thing, instead of doing this, would be to also have a PortAudio unique pointer, and I know there's no object that represents it, but something that captures the scope of it, so when it runs out of the scope, it will sort of deinitialize PortAudio anyway. But I think that's for the future. Let's keep it up there. The reason why I'm saying this is because all these early returns, you know, they won't work. I mean, it's not necessarily going to work. I mean, not necessarily going to not work, but I definitely won't be deinitializing the audio device properly because deinitialize hasn't been called. So maybe, yeah, maybe we're going to do that just for the sake of it. I mean, this will be a to-do for the actual PortAudio settings. And really, you can only have one pointer of this at a time, right? Because I assume if you initialize it twice, it's not going to work. But this is just a hack for now. That's going to allow us to have the early return, to have those early returns everywhere. Because when the pointer goes out of scope, you know, unique pointer is going to deinitialize it for us. And that's what we kind of want, really. Okay, so now we can do a PortAudio pointer. It could be a, or I'm going to use it. It should be a unique pointer PortAudio there, and then PortAudio destroyer. And then we can have up here the actual destroyer. I mean, yeah, I need to rethink this. And then this, instead of returning a boolean, it would be, you know, a PortAudio pointer, really. And in here, there you go. This is the kind of logic that I'm thinking of, really. Just for the sake of it. If it can be destroyed, that's when we call the, you know, the stop or whatever it is here, PA terminate, right? Which is the counter to PA initialize or something. So we're just basically getting the smart pointer to do the work for us, you know, to get all the logic correct, so we don't have to say, you know, if this stream terminates early, then we're going to return, but before we return, we have to do the error handling, which will be, you know, stopping the initializing PortAudio and all of that stuff. So that's what we're moving into. And I need to change all these functions so it's all consistent with the naming, because I'm using camel case and then underscores in some of them, but we'll get there. Anyway, so this is what we need here. And we don't want to throw an error because it's a destructor. And this is just going to be the error there, and then the error here, and get error text or something. Error message, and then boom. This is kind of what we want, really. So, I mean, if there is an instance active of PA stream here, in other words, if we initialized it using the function that we're gonna use underneath, which, you know, will create the oh no, dude, this is the wrong place to put the code, isn't it? Wait, what? I am confused now. Okay, you were supposed to go over here. Yeah, there you go. You were supposed to go over there. I just realized that I put in the wrong function, but that is okay. This stays as it is. We're still gonna close the stream. It should be here though. This is where we really care about. There. we're not going to return it. Yeah, we need to rethink the logic here, basically, regarding this song is wank. Okay, so that sounds okay now. Okay, that sounds good. We can initialize the PortAudio, but yeah, let's just call initialize PortAudio. And now, whenever we use, we can just store this in a variable in the main function. Right? Yeah, so we would, instead of this, we're just gonna do something like this, auto PortAudio instance here. And you know, this is automatically captured in a unique pointer there. So basically, whenever we do an early return, such as here, if we fail to start the stream, then we're going to return. But before we return, C++ is going to remove, or is going to deinitialize PortAudio, and is also going to, I guess, stop the stream. I just can't remember which order things happening really. C++ out of scope destructor order. In the reverse order of construction. So the first one's first, right? Yeah, so it makes more sense now. What part of the standard guarantees this? A different part of each category for objective. Yeah, in the reverse order of allocation. So that is good. That's what we want, really. Yeah, cool. Because it is a stack at the end of the day, so. I was just making sure that the standard guarantees that, though. Because I'm not... I mean, Stack Overflow doesn't really say that. What's the order that local objects are destroyed? And this is from the ISO CPP. In reverse order of construction. First constructed, last destructed. Okay, cool. So we are fine with this code. Because then the stream would get destructed first, which means it would stop the stream or close the stream, and then PortAudio would get initialized. Okay, so that makes the logic a lot simpler. And we create a default stream. And obviously, if the stream is not a valid object, so if it's a null pointer essentially, we're going to return -1 here. Okay, so this is the check that we forgot as well to put in now. And then we can play everything, and then we can stop the stream here. I guess we already have a... Yeah, no we don't. So let's just do a CL here. fmt.format. Here to stop the stream. For now, I'm just going to do this. I'm going to return a -1. So this should still compile. And in fact, if we look all of this, we'll finish with -1. So let's look at the first error. PA test data undeclared identifier. Okay, so it should just be PA stream data. And again here, it should be a PA stream data. And this should go obviously after the stream data definition, which is around here in the... in here somewhere, right? Yeah, there you go. we need to have a bigger look at this function because this callback, it's ridiculous. So that's going to definitely be one of the main things that we're going to be refactoring in the future. Does it compile now? Yeah, cool. So now it does compile. And what have we done here? So let's have a look at the git diff. So we moved the PA callback, that's fine. We created the struct for PortAudio, even though it doesn't hold anything, it just represents the PortAudio initialization. That's what we wanted, and we created the unique pointer for it as well. There's a PortAudio pointer somewhere that's got a lot of spaces. Is it here? Yeah, it's here. And then a PA test callback. This has a lot of random stuff in it. So like there's one. User data, there's one as well. Like empty spaces, basically. Then on this here. Okay, cool, that's gone. And we created functions to start and stop the stream given a PA stream pointer, valid pointer, that is. So if it's not valid, it's going to return early. There's another one here after the start stream call, okay. Cool. And now we should be okay to basically create a new branch as well. What should we call this one? This is more unique pointers. Oops. Origin, okay. And obviously we can merge it in. I mean, I'm going to be bypassing my own rules, but oh well. It's good to look at the code that you've written at least once you've done it. And a UI like this can definitely help from GitHub. So yeah, we've obviously moved all of this stuff into here. We haven't touched it at all apart from moving it. And then we created a struct for PortAudio, even though it doesn't store anything. It's just so we can use the unique pointer for it, basically. And then we created the PortAudio destroy function. And then the initialize PortAudio, which will return a no pointer if it cannot initialize, which is fine. And also a PortAudio pointer that is actually valid. It doesn't store anything apart from a number 1 inside the struct. And then the PA test callback there, the start string functions, the start and stop string functions. And okay, there's no new line. We can add that, I guess, at the end of the file. And it should obviously be here now. There you go. Okay, we can merge this. This is fine. Before we do that, let's actually compile, right? Probably a good idea. See if it still works. Damn, that water was juicy. Okay, cool. So it does work still, which is nice because now we have a more stable sort of API that's not gonna mess up if there's an early return out of nowhere, because all of these unique pointers that we have inserted to control the destruction logic. That's definitely a plus for us. Let's actually merge it without this. Okay. Okay, I'm gonna go, but I'm back now. Lucky, Mini. There you go. A little bit better now. Right, so I don't even know what we stopped actually. Did we merge it in? I think we did. Yeah, so no, the only thing I don't like still is this, because we have an array of nodes here, and each of them has a frequency, but I'm basically repeating the information. This would ideally be a map, like yeah, maybe we can do something like that. So for this particular program, let's write the nodes we need in here. So perhaps not an array anymore, but let's bring the node up here. Let's bring all this stuff to the anonymous namespace. So everything is down here. I forgot to bring this up as well. Okay. I don't think we need an array anymore, but we do need a map though, so in fact, not even that. It would just be like an unordered map, right? Where we can guarantee that the operations will be Note ID is undefined. No, it's not. No, we don't need the frequency anymore. No, wait. Let's keep our array there. I'm getting tired. Can't think anymore. Either way, we're gonna need something like this, right? And then instead of that, let's just do a float there. No ID is there. No ID is here. No ID in the frequency. Okay, so and this will be our notes. No frequencies. And then the map. The array can stay here though. Oh, now I've lost it. Oh. Easiest thing for now. I'm just gonna see what I did was. And then just gonna copy and paste this basically. Okay, so this is better. No ID undeclared identifier. Oh yes, note, isn't it? Okay. So we have a map that says the note ID and the frequency that it has. We have a struct for the note itself that is a note ID and a time, it should be. Time in milliseconds. And yeah, I mean, we're sorted, except this bit of code here that obviously won't work anymore. So what we need to do is to get the note.id. This will be a switch case really, so bring it there. We have a division, don't we? Something divided by the frequency, so ooh. Oh, maybe we should put this into function actually. And line is somewhere. But this is getting quite big now. We're gonna have to split into a different. Oh, we have a map already. What am I saying? Let me just look up something. Okay, so same thing as before. Song is wonk as well. Okay, so optional is not here. Now frequency, what do we do though? We set the frequency to this. See, I don't even know now. I want to essentially bring the step to zero, don't we? Or do we just want to terminate the program or something? Now this should still work. Cool. Where are the arrows? No, milliseconds. Okay, so this is actually telling me milliseconds, and that's where we have what we want to. There are warnings, right, to possible loss of data in where? 9193. What? Where's it 54? Double to float. Okay, so all of these, I guess. Let's see if some of them disappear. Okay, cool. We got rid of all the warnings and it should still work. Let's make sure it does. Cool. Okay, cool. Now the wise thing to do would be to put all of this PortAudio stuff in its own library so you can get rid of all the PortAudio includes, well, not get rid of all of them, but put some of the functionality somewhere else and keep this file a little bit more clean. But at the moment, it's okay. One thing I need to look into is the creation of a data structure that actually is not going to give me any data races. And this would be done with a queue, but a lock-free C++. I don't want to put boost in my build though, but it does look interesting. Lock-free queue. Let's take a look at this guy's code. I just want to look at the code really. It's 18 contributors. Interesting to use it. To implement it. I didn't want to include boost, but it seems like the only viable option we have is putting boost in there. So let's have a look at what it does in the first place and how it does it, I guess. So there's one as well. Alright, this is something for tomorrow, so I'm gonna do it tomorrow, I think, but it's something to look at really, because we need a queue that is basically what it says here. It's lock free, wait free, and guarantees that operations will be done in a finite amount of time, which is good. Well, not finite amount of time, but you know, it's not gonna be blocked by anything else, which is what the callback needs. Song is also shit. Okay, so this sounds interesting. I'm gonna end the stream here, so I'm gonna go to bed.